Hi guys, I'd like to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. In today's discussion, we're going to look at one of the organic reactions on epoxidation. And this basically follows one of the videos, two other videos that we have done on the concept of epoxidation. And we have decided that this is a process that is going to lead to the formation of what we refer to as an epoxide, which basically was a three-membered cyclic ether that we had said which is going to be formed as a final product of this particular process. So therefore, we have looked at some of the reagents that were employed in this specific case for the formation of epoxides, and we had said that one of the reagents that was being used was a peracid, which basically we had given this particular condensed formula in that particular respect. Now we have decided that this peracid basically is a compound that is of a carboxylic acid nature, but it consists of three or an extra oxygen in its specific structure. And then next we had looked at the mechanism of rearrangement that this particular peracid was going to undergo in order to form this particular final product or initiate this particular process of epoxidation. We mentioned a few examples of this one whereby we said that if this particular radical is substituted by a methyl group, then this is going to form what we call peracetic acid. And if it was substituted by a phenyl group, and then we said that that is going to form a benzoic acid. And in this case also we say that if this particular case for this group has got a substituted phenyl group, then this is going to form what we refer to as a metachlorobenzoic acid, which we said is going to be basically of course involved in some of the organic reactions, especially on most topics that we're going to learn on organic synthesis. So for today, basically we're going to look at another way in which we can be able to obtain an epoxide. And this is basically due to the fact that whenever we are trying to perform this specific reaction, there are some cases whereby we're going to see that the product is going to be formed at a very fast rate. So in cases whereby isolation is required, and therefore we're going to require some of the reagents that is going to, of course, be considerate in so far as the rate is concerned. And then next, the effect of the byproduct like the carboxylic acid that we had mentioned, which are going to be formed, are going to have an effect on the final product which is going to be formed. So therefore, the concept of oxidation, therefore, in this particular case is going to be achieved using what we refer to as dimethylioxirane, which basically is a compound that we're going to illustrate using that specific formula. So therefore, this is the compound that is going to be used in order to achieve that particular objective. And we're going to see that the preparation of this particular compound, as we had seen the preparation of peracids, basically involve the reaction between one of the ketones. We can use acetone. We can use acetone in the presence of what we refer to as this particular compound of potassium. And then we're going to see that this is going to result in the formation. I can basically use this particular illustration, whereby we are going to have this acetone reacting to form this particular peracid in the presence of this particular compound. So this is the compound that we are referring to as dimethylioxirane, which we are going to use in the of course in trying to prepare our epoxides. So if I try to give an illustration of this specific reaction for epoxidation using this dimethylioxirane, I can just give we just use this. So I can use this specific example for an alkane group that is going to interact with this dimethylioxirane, whereby we're going to see that this is going to act as an electrophile, and this is going to act as an electron-rich species. So therefore, we're going to have the alkene molecule interacting with that one. We had seen this case taking place in, especially in the concept of halogenation, where we had considered a bromine molecule coming closer to the double bond, and therefore having this effect of polarity, whereby these electrons are moving towards this other side, therefore making this particular part of the molecule behaving as an electrophile. So in this particular case, the interaction between those two molecules are going to result in the formation of an intermediate, whereby we are going to have this one being illustrated as such, whereby this is going to form a positive, partial positive group, and this is the electron rich part, which is basically going to be this specific part. In this case, we can just roughly put those ones are just radicals in this specific point for just illustration, and then we can be able to show the rearrangement that is going to take place at that particular intermediate, which is going to lead to the formation of a final product. So in this particular case, we say that these particular ions, of course, can undergo rearrangement, whereby we're going to see that this particular charge is going to move at this point, and this is going to move in that particular direction in order to form that epoxide. So the resulting product from this particular reaction or rearrangement, therefore, is going to form that specific product plus this particular acetone that we had given as our first reagent for preparation of what we referred to as dimethylldioxirane, which was basically the reagent that we were using to form an epoxide. So basically, this is a summary of the reaction mechanism that is going to be involved insofar as it is a reaction of alkenes to form epoxides are concerned. And this basically, we said it is a reaction or a procedure that we're going to employ whenever we find that the epoxides or the products that are produced are too reactive to be made using the peroxide acid we had initially used in our first case. And if we, in any case, we are going to consider the aspect that the final product that we had said, of course, we said that the products are going to be a peroxide and the carboxylic acid that was going to be formed. So this is going to determine the achievement of the final product, or how we can be able to separate the final product from that one that is formed. So in that case, of course, we're going to just stop this one, this particular point. But we're going to look at other ways in which we can be able to achieve the formation of epoxides from other reactions that we're going to mention later in other videos, like the nucleophilic epoxidation, etc. So we shall stop there for now. Catch us in our next video, guys. Bye. God bless.